Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of Pythagorean Theorem on a coordinate plane. This is standard 8.7D in the great state of Texas, and we are using item number 27 of the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have the coordinates of an endpoint, QR. They give them to us, 8, 2, and 5, 7, but they are pretty easy to find on our own. We are in quadrant 1 here, so everything is positive. We just need to find its length. Now, rather than just trying to guess how many units it is, because it is a diagonal, an easy way to do this is to view this as a right triangle. Now, it doesn't look like one, but what happens if we just put a dot right there? So you could take any straight line on a coordinate plane, and you could turn it into a right triangle. You just pretend that that diagonal there is going to be the hypotenuse. So this dot that I placed here is directly to the left of Q, and it is directly below R. And if I do it like that, I make a right angle, and when you make a right angle, everything opens up for you, because we know that these two sides that make up the right angle, those are called the legs. We know that this side that is directly across from the right angle, the slanted line, is the hypotenuse. And we know that there is a formula, this Pythagorean theorem, that we can actually use. A squared plus b squared equals c squared. So when we're talking about that, the two legs are always labeled A and B. It doesn't matter which one is which. And so what that means is pretend that this side length B, this leg here, is just the side of a square. So that means it would go down. We're going to be off our little graph here. And then same with this A. Pretend that this is the side of a square. And if you take the area of these two squares, a squared and b squared, and you add them together, you would always get the area of this c, the hypotenuse, if that was the side length of a square. So a squared plus b squared always equals c squared, regardless of the size of a right triangle. That's the Pythagorean theorem. And so how does that help us? Well, if we know the actual distances, we can use that to find missing lengths. And we have this missing length, QR, which is what we're looking for. All right, so this A right here is this distance between R and my point, and it runs from 2 to 7. So we're going to say A equals 5. B, as you can see, goes between 5 and 8. That's just going to be 3. All right, so let's plug this in. So 5 squared, plus 3 squared, I'm just replacing my A and B with 5 and 3, equals c squared. Now that does not mean 5 times 2, that's 5 times itself. 5 times 5 is 25. Same with 3. 3 times 2 is not what we're looking for. We're looking for 3 times itself. 3 times 3. All right, so we've got a 34 equals c squared. Now we're not done. Even if we thought we were done, obviously there's nothing really close to that, but it's because we have this exponent here. And in order to get rid of an exponent, we need to use the inverse operation, which happens to be a root. So since it is a squared, c squared, we're going to take the square root, and that will actually cancel itself out. So c equals the square root of 34. Now we can use our calculator if we want to, but we can probably estimate this. So square root of 34 equals c. Right below that, we're going to get a 25. That's 5. And right above that, actually we're pretty close, is 36. That's going to be 6. You notice that we're 2 away from 36, but we're 9 away from 25. So I'm thinking like 5.8 or something like that. Maybe 5.9. Really close. And because we're only 2 away from that 36, and as you can see, we do have a 5 and a 4, but A is going to be our best answer, 5.8 units.